Hi guys, in this video we're going to talk about comparing order of growth using limits. You can also use this method to prove things, but usually you're just kind of comparing two functions. So remember limits. So we're going to use them, so if you don't, go brush up on limits. It's not too hard, and I think even if you start from here, you'll get it. So we're going to hijack the limits that we learned in calculus to do this comparison for us. Okay, so we're going to define this piecewise function where the limit as n goes to infinity of our work function t of n over g of n, which is going to be whatever is inside, big O or big theta. So, and we're going to define the output as c, and we're going to define it this way. If c is 0, then we're going to say that t of n is in big O of g of n. If c is anything between 0 and infinity, then it's going to be in big theta of g of n. And if it's infinity, then it's going to be in big omega of g of n. Okay, so this holds for everything, all the functions you can think of. Okay, so let's do some examples. So I may pose something like this. I may say compare these two functions. Compare 10n and n squared. Okay, so you want to set things up. It really, when I do this compare, it really doesn't matter what you decide to be your t of n and your g of n. You'll just maybe get opposite conclusions, right? So if you choose your g of n to be n squared, you may get something different than if you choose 10n, but they're equivalent. They'd be the opposite conclusion, right? So both would hold. And I don't know if I've already done this one. Oh, I haven't. Yes. Okay. So the first thing that you should always look at when you're doing these is simplifying. So here I have an n on the top and I have an n squared on the bottom, so I can cancel, and this will become 10 over n. And so now I want to apply this limit. Once I can't simplify anymore, I want to apply the limit. So this is going to be 10 over a really big number. So this is going to basically be 0, right? So 10 over something really large is going to be 0. So now that means that we have proven that 10n is in big O of n squared, right? So that's the relation. So we compared the two, and that's what we came up with. If you had chosen the other way, so say you had decided to say n squared over 10n, right? Then you would get n over 10, and then when you put this limit in, you would essentially get 1/10 of infinity. 1/10 of a really big number is still a really big number. So you would get infinity, and that would mean you'd come to the conclusion that n squared is in big omega of 10n, right? So, right, you would come up with opposite conclusions, and both hold. Both are completely legitimate, and I would take either one as an answer. Okay, let's do a more complicated one. And this one is a little bit more complicated because it doesn't work at first. So here you can't simplify any, so you go ahead and you plug in infinity. So infinity over infinity is not infinity. So infinity divided by infinity is not infinity. It's undefined. So this is undefined, or undetermined. So what you have to do here is you have to use L'Hopital's rule. So what L'Hopital's rule says is that the limit of t of n over g of n as n goes to infinity is the same as if you take the derivative of the top and the bottom. So these are going to be the same. So now what you can do is, instead of putting it in and getting something undetermined, you can solve it. And I'm going to erase this because I want to do it again. Okay, so so t of n equals log n, t of n prime, so the derivative of log n is 1 over n. And this is not a calculus class, so I'll give you all of this, or I mean you're at home, so you can look it all up, which is fair game. So this is 1 over n, and then g of n equals n squared, so g prime of n is going to equal 2n. Right, so if we go ahead and do this, we get 1 over n divided by 2n, right, which is really over 1. So then you have 1n, if you bring this up to the top, times 1 over 2n, right? And now you have 2n squared, which is going to be 1 over a really, really big number when you plug in infinity, right? Which is going to be 0. So you get the conclusion that log n is in big O of n squared, which totally is. It completely is. Okay, so another example. Now I'm saying prove. So you can use this to prove. Sometimes it gets a little bit ridiculous because you have to use L'Hopital's rule several times. Right, you can take first derivative, second, third, fourth, fifth. So eventually it sometimes becomes a little bit tedious. So you might at that point want to go by definition. Or I may tell you, you have to go by definition. So let's go ahead and set this up. Let's say n cubed minus n squared plus 1 over n squared. And I'm trying to prove that this is in big omega of n squared. Now, just by looking at it, I'm going to say that this is going to come out false because no, maybe. Okay, I thought I had set this up to actually come out false. Okay, so let's just go forward with it. So here you can do some simplification. Remember, you need to separate out by terms. Minus n squared plus 1 over n squared. It's the same. And now we have n over 1 minus 2. Yeah, they both cancel. Plus 1 over n squared. Okay, so now we have infinity minus 2 plus 1 over infinity. So infinity minus 2 plus 0. So infinity, really big number. And so we proved that that is actually the case, right? So it is, so we got infinity, so that means that n cubed minus 2n squared plus 1 is indeed in big omega of n squared. Okay, so I'm going to do another example of this. So there's got to be an easier way to do this, but this is kind of actually satisfying. Okay, so, oh no, come here. Okay, let's go ahead and say n to the 4th. So this should not be the case at all. So let's go ahead and try to solve. So limit as n goes to infinity of t of n over g of n. So this is going to be, again, n cubed minus squared plus 1 over n to the 4th. And we're going to separate out 2n squared and 1 over, okay. And we're going to get 1 over n minus 2 over n squared plus 1 over n to the 4th, which is going to be 0 plus 0 plus 0, right? 1 or 2 over a very large number. And this is going to be 0. So if this were to happen, and I tell you to prove this, you would say it's just false. This is just, it's false. This is not true. And you could say, in fact, n cubed minus 2n squared plus 1 is in big O of n to the 4th. So it may be something like that. I may say prove that it's not in big omega of n to the 4th. So there's some variations on this, but it's the same basic process, and it's pretty straightforward. So please let me know if you have any questions. This is a chance to kind of brush up on your calculus just a little bit, but let me know if you have any questions. Thanks, guys.